The final equivalent capacitance circuit that we have to look at has a new little wrinkle in it for us, but hopefully that won't be too confusing when we see what is going on. But we have this diagonal C4 capacitor in here that sometimes can throw us for a visual loop, but please don't let the difficulty in visualizing the circuit initially keep you from your analysis process. And that analysis process is always same color, same voltage. Start at the battery, our 10 volts on the positive terminal of the battery, our 0 volts on the negative terminal. Same color, same voltage. So get the red and the blue into the circuit as quickly as possible. And then look at the other parts of the circuit to get our same color, same voltage, as long as it's metal touching metal. We have the green, and of course then our yellow becomes less intimidating, that diagonal, when we see that it just falls into our same color, same voltage scheme. Now, I will always try to solve the circuit from right to left, backwards towards the battery if I can, and in this case my eyes were immediately drawn to C4 and C5, same color on the top, yellow, same color on the bottom, blue. So I put 4 and 5 together since they were the most apparent to me initially, and redrew the circuit. So when they're in parallel, they end. That's when we get the 6. Now things begin to fall into place a lot more quickly once we get that first initial step into the process. So here I see that 3 and 4, 5 are in series. Same charge is flowing through 3 as 4, 5, so those are in series. So I put 3, 4, 5 together. Please check my math. They add reciprocally, and now it's really beginning to become clear to us. We have 2 in parallel with 3, 4, 5. So I put capacitor 2 and 3, 4, 5 together. And then we have our final step before we get our equivalent capacitance, where we have capacitor 1 in series with 2, 3, 4, 5 to get our equivalent capacitance. So as we have done before, I'm going to step back here, ask you to pause the video, check all of the calculations to get the equivalent capacitance and the charge on the equivalent capacitance, because we're going to work our way back. So pause the video and check that. Okay, so hopefully those numbers make sense and the equivalent capacitance is firmly in place. And what we are going to do is what we've done before, work backwards. We are going to see that the charge on 1, 2, 3, 4, 5, right, is the same charge on 1 and 2, 3, 4, 5, the 40 coulombs. So now we know everything about capacitor 1, namely we know the voltage on capacitor 1, the voltage drop across capacitor 1 is 5 volts. So we had 10 volts on the capacitor, and we drop 5 volts, so that's why we get 5 volts here, and that gives us our green voltage is actually 5 volts. Now, we're going to keep working our way back up, so we see that the 5 volt drop is the same across capacitor 2, so now, as it shows here, we have everything. We know everything about capacitor 2, meaning we now know the charge across capacitor 2 is the 25 coulombs. Once we know that charge, we can go and look at 3, 4, 5. We know the charge on 3, 4, 5, because it's that same 5 volt voltage drop, is 15 coulombs. And then when we look at the circuit above, so we know 3, 4, 5, just to recap, we know 3, 4, 5 is 15 coulombs. So that means we have 15 coulombs, 15 coulombs up here. And we have 15 coulombs on 4, 5. So once we know that 15 coulombs, we can get the voltage drop across capacitor 3, which is the 2.5 volts. And when we look at the voltage drop, again, the numbers here kind of worked out nicely. So the voltage drops and the actual voltages turn out to be the same. The 5 volt drops 2.5 across 3, so the yellow in this case is actually 2.5 volts, and then of course 0 volts down here at the bottom. So we have the complete circuit, and I'm zooming back out here for you to pause and look at all of the numbers and the analysis that I've talked through here. Make notations so that if you have questions, we can kind of quickly and efficiently get them straightened out if you need to talk to me in class about it.